Hi there, welcome back to the channel. Welcome to video number 4 in the restoration series for this Philips Reverbio B7X14A. And this is where we give this guy the feature that gave it its name. This is a Reverbio, so the big selling point on this radio was the reverb function that they had in there. Quite honestly, I don't really know what the idea was. Some have said that it could be an attempt to get sort of a stereo effect from a mono station, from a mono music station, for example. I don't know. And I've never heard it on a radio like this before. I'm curious to hear what it sounds like. And I'm also a little bit, I was a little bit afraid of what I was going to find when I started restoring the actual reverb circuit. I mean, things could go haywire. There's a germanium transistor in there. There are little springs everywhere. There's quite a few capacitors that probably need changing. There's also the actual reverb unit that's got two little solenoid type transformers on each end. I don't know if they're working. I don't know if they're open or not. I certainly know they've been disconnected from the cabinet, from the chassis. When I got it, the reverb unit was just sort of lying across the top, so it doesn't seem to have been working. So the idea was, let's focus on reverb. This is going to be my job today. I want to get the reverb working, see what it sounds like, and hopefully find out that this thing really deserves its name. If this sort of thing interests you, stick around, enjoy the video. But before we carry on, I just want to thank the sponsors of this video. That's PCBWay. If you visit their website, you'll get all the information on all the services they provide, from the simplest PCBs, which is what I normally use, to all the advanced PCBs you can wish for. Furthermore, if your project requires it, you can get prototyping done, you can get assembly done, you can have CNC machining done, and also 3D printing. So your project can go from your design all the way through to a finished project. And just as with the PCBs, with all these services, you can get instant quotes online for whatever it is you want to do. Visit them and see what they can do for you. I must admit that I've been curious about this bugger since I first got this thing. And if you recall, this thing was just lying loose on the top there. So it was definitely not connected, not working. But it's a gimmick, and it's a gimmick that piqued my curiosity. And I say it's a gimmick because, quite frankly, I honestly don't see this thing being used. I perhaps would accept that in the past, when you're listening to music on AM and you wanted to get a sort of a pseudo stereo sound, something, I don't know, wavy, you might use this. It does create a delay, but nowadays, I don't know. However, this is a restoration, not a repair. So the point is, regardless of whether we're going to use it or not, we have to fix it and we have to test it. And before we do that, we have to clean it. So I'll be doing that. But before the cleaning part, I just want to show you what I've done on the circuitry itself. Let's go to the schematic for a second. Here is the schematic for the section that deals with the reverb. And we've seen this before, but let's just quickly go over it again. This time I hope I don't make the mistake that I made the last time. This point here is the cathode voltage of the two power tubes. We can see it here. There's the cathode. Those two cathodes are tied together. And just so you know, I've seen a couple of references to people separating the cathodes, and that actually would make sense. These two cathodes are being biased by the same resistor and the same bypass capacitor. Now what this does is it creates a voltage because of the current flowing through the two tubes. That one plus that one go together through that resistor, creates a DC voltage. That DC voltage creates a bias voltage reference to the grid of that tube and the grid of that tube. However, here's the problem. If there's a problem with one of the tubes, let's say there's a problem with this tube, if it allows more current to go through because it's, well, defective, then the voltage created here will also appear referenced to the voltage there. So these two tubes will start acting differently. The effect on one will affect both because it throws off the bias. That's why people take this wire here, this one, separate it, and in this case they would put another resistor to ground, another capacitor to ground. What you probably do here is, we've got 82 ohms, so you probably put about 160 ohms or 150 if you want to go for a standard one, and probably about 80 microfarads or 50 microfarads on each side. So the tubes then would act independently and one would not affect the other. But that's a by the way. This point is a more or less fixed DC voltage. It does vary depending on whether you select FM or AM, but it is a DC voltage and it serves as a supply to this circuit here. Now this circuit here does not draw much or too much current, but anyway, it is there. So this thing supplies this section of the circuit. And again, because we're dealing with a PNP and it's germanium, just to make it more fun, this is all sort of upside down. But never mind, this is the positive. This creates a voltage divider to ground, so it creates a bias point over here. This is 33, this is 47. So this will be, what is that, 90 or 80. So 5/8, okay, about 0.6 of that. So that'll create a bias voltage. That then is the bias voltage, which then reflects to here, to the emitter, with about a 0.1, 0.2 volt drop. Actually, it says here 4.2 volts, 3.9 volts at that point, which means that this thing will have the 0.2 volt drop, or 0.1 for a germanium. And that then will create a current flowing through this transistor. That's at your bias point. And that current is, well, actually they create another sort of stabilized supply here. This is a break to create a sort of semi-stabilized supply and isolated from that one. This capacitor just filters this so it doesn't have any noise coming through. And then you've got yourself a normal amplifier, right? Whatever comes in here is going to get amplified and it's going to get fed through whatever load is on here. And there is a filter to ground. So from here to ground, you've got a 3.9K and a 15 nanofarad capacitor. So some of the higher frequencies, there's a shelf that happens here, gets filtered to ground. The remainder goes through this 47 nanofarad capacitor to drive a load, which in this case would feed in to, where would it feed into? It would feed into, well, it would end up feeding into here, some to the audio coming out of the one side, only the one side. But what I've done is I've checked all this. I had to replace these capacitors. They were all gone really badly. I don't think this has got to do with voltage, because this is low voltage over here, but it probably just has to do with age on electrolytics. So these were all replaced. Everything else measured fine, including the transistor, which was quite satisfying. But I did measure that. It gives me a PNP with a HFE of about 50, I think it was, and it seems to be working fine. So what does it do? Well, what it does is it receives a signal from here through this capacitor. And where's that signal coming from? If we follow it, it's coming out of this tank. It literally comes out of this tank. There's an input there and an output. So it comes out of the tank and goes through into there as an audio signal. What does it sound like? Well, it really sounds a little different to what we'd expect, because we've got an input over here which is being fed from the speaker output. So whatever speaker output you've got here, whatever speaker signal you've got here, comes in here, goes in there, and it actually activates a little transformer. A transformer which has a mechanical effect on the springs. And I'll show you that when we go back to the module. It activates a transformer which moves those springs in harmony with the audio coming in here. It's going in there and it's activating this transformer here. That goes bang, 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 bang through the springs, and it comes to this side and it comes out of here as through another transformer which takes the mechanical action, the physical movement, and transfers it back into an electrical signal. Here it's going from electrical signal to mechanical movement, and here it's going from mechanical movement to electrical signal, sort of the same thing as a motor dash alternator. So it comes out here as an electrical signal, which is a reflection of whatever comes in there. Now, obviously, you'll have the spring effect, which can be quite dramatic, at least in guitar amps. I'm used to them, but I've never seen it on here, which is why I'm so curious. And it comes in, and then it goes through and feeds it to the speaker again. So electrically, it's not a big deal. Mechanically, it's very interesting. See, mechanically what happens is the signal's coming in here from the speaker, okay? It's actually coming from this, through this resistor from the speaker output, and it comes to here, and it then goes into this guy. It goes into this transformer, which is referenced to ground, and it creates an electric field around this core, which in effect moves physically the cores or the, I don't know what kind of metal's in here, but whatever it is, it gets moved physically by the electric field that's being generated on this core. So it's sort of the effect of a solenoid, probably the same sort of thing, like a solenoid. Maybe these guys are magnets, I'm not even sure. I can find out. Not sure. But anyway, the point is that your electrical field going in there is moving these guys, and these guys make the springs move, okay? Now, on this side, we've got exactly the same thing. We've got these two mechanical things here, which are moved by the spring when it gets to this side. Now remember, if you've got a wave that's hitting on that side, it's going to go... Didn't that sound like a reverb? So it gets in there and it's moving this thing, which then creates an electrical field on this little coil over here. And that then comes out here, reference to ground. So what I need to check quickly is that these coils are intact. Let me do that. One other thing you'll notice is that this wire, these wires are very, very flexible. They're sort of cloth covered. And the reason is this thing has to be suspended on this, on these springs over here. So it doesn't have a sort of fixed mechanical dampening to the chassis. It really is sort of floating in midair. And the reason these are so flexible is so that it doesn't affect the, it doesn't create or add any physical dampening to this reverb tank. Most reverb tanks are exactly like this, guitar amp ones as well. They just happen to be in a better enclosure, I guess. But they're very, very similar. So let's check the continuity on these guys. Make sure it's working well. So as I said, this is just a coil, so we measure for continuity. Yep, 185 ohms. Let's see what the other side looks like. Huh, 185 ohms. Exactly the same resistance on both sides. So this guy's good, which is a relief, because otherwise, even as a gadget, it would be totally useless. Now what I'm going to do is just clean the stands where these things go on and clean the tank itself and put it back, and then I've got to solder these respective points on there. See if I can still use this, this wire. Damn, it's looking a bit frayed. I might have some very flexible wire here that I can replace this with. I'll have to see. All right, it's back on. And it's springing nicely. The springs are holding it to the top, so there's no direct contact with the chassis itself. The transformer, I put in very, very thin wires in there, new ones on both sides, soldered it to the respective points on the back there, and I'm ready to try it out. I'm ready to try it out. Let's set it up and see what it sounds like. Okay, here goes. I've got Bluetooth coming in there from my Aerolink Bluetooth streamer, which I'm using as a line level input source at the back in stereo. And what I have here at the moment, I've got it on stereo input, hi-fi. Now I'm going to try and get you to hear the sound properly. I'm putting this at the back, putting the microphone at the back of the speaker, so you're not going to get the real effect, but it'll give you an idea of the difference. Let's try that. That's just normal. Sounds pretty good. Now I'm going to activate Reverb. That sounded kind of weird. Really weird. Let me try something else. That is really a strange effect. It is really strange. Now let me show you something. I'm going to pause the music. So we've got nothing coming out of here. You hear nothing. When you put reverb, there is a bit of buzz. And the reason for that is that this thing is effectively an antenna picking up the hum from the desk. When this thing's in the cabinet, it'll be better. But if I hit the reverb tank, you can see the springs in there. Can you hear that? That is strange. Okay, so the reverb is working, and I'm not sure that it's useful or not. I think you noticed that when I put it on the stereo without the reverb, just by the way, just so we know how this works, these three unlatch each other, okay? And I'm going to do this slowly because I'm still worried about that switch. If I hit this one, that one pops out, that one pops out. If I hit this one, that one pops out, right? That's mono, that's stereo, that's reverb. So what we see here is that any one of those can only be in one at a time, okay? And these two are the ones that pop each other out. You see, that hasn't been glued, but these two pop each other out. So that means that you can't use reverb on stereo. It really only works as a mono add-on, which makes sense because that's what your AM radio would be. Switch that off. And I'm curious to hear what it'll sound like on an AM music station. We've got one in Madeira, one station in Madeira, period, and it plays quite a lot of music. So when we've got this radio section working, I'm curious to hear what it sounds like. Also, I'd like to make sure that the speakers are facing forward so we can hear it from the front. These things are pretty cumbersome. That's why we had to make do with the way it is there. Now, as I said, this thing is a gimmick. This is what gave this particular model its name. It's a Reverbio from Reverb. So I guess they did think it was important at the time. Whether it's important now or not, different story. But I had to get it working. That's the whole point of restoration. You get it working whether you're going to use it or not. I mean, how many people are going to listen to AM stations? Well, I suppose, you know, shortwave maybe, medium wave maybe, long wave, very few. The point is we've got to get everything working to call this restoration a success. And I'm going to call this part of the job a success because I was actually quite, well, I was afraid of a few things. One is I was afraid of those little transformers on the reverb tank. They're pretty fragile. I've seen quite a few of these things bust on guitar reverb units, guitar amplifier reverb units. The other thing was the actual transistor, the OC71. You know, that's a pretty old transistor. I think I could probably replace it, just rebiasing it a bit. I think we could get that thing to work with a modern silicon. Shouldn't be too difficult, but that one's working just fine. And quite honestly, I was surprised when I switched this on and I was testing it and found that it was working as it's supposed to. Whether you like it or not, that's a different story. I like the fact that it's working. That's enough for me. And that's enough for today. So I want to thank you all for your company. I hope you've enjoyed that. I hope you've learned something. And if you did enjoy that, click like, share, subscribe, and all that jazz. And if you do want to support the channel, you can do so on Patreon. And once again, thanks for watching. Bye for now and stay safe.